Hi everyone, my name is Casey Taylor. I'm from the University of Delaware, and today I'm going to talk about stakeholder perspectives on how best available science should be defined. And best available science is a concept that we run into regularly in environmental policy. Most famously, it's raised in the Endangered Species Act as the standard for which several decisions are made. And it's also present in several other of our major environmental laws. However, that it can create some confusion because there's no standard definition that is generally accepted. And so lots of folks have tried their hand at suggesting definitions for it. And this chart is just an example from Ryder et al. From their 2010 paper, where they looked through the science policy literature and tried to identify all these different attributes that different people were suggesting for how the best available science should be defined. And while they found a wide diversity of attributes, they also observed that none of them, were included across all or even most of the different studies that they looked at. And so there's certainly a wide variety in perspectives over what should be called the best available science. And this can create some challenges for science and policy. If scientific analysis is too divorced from social and political context, it can undermine its own ability to be applied to assess the potential outcomes of different policy options. And secondly, we also know that conflicts over data and science within controversial issues are often expressions of underlying value conflicts among stakeholders. And these two things together made me wonder, what about those stakeholders who are actually involved in the issues? How do they define this concept of best available science? We have all these definitions offered in the academic literature. What are their thoughts? And more specifically, considering the rising popularity of collaborative models for conservation, how do stakeholders involved in those efforts define the concept of best available science? And so that became my research question. And in terms of how I answered that question, I collected data in 3 states, in Oregon, Wyoming, and Idaho, as part of a broader project looking at collaborative conservation efforts for the greater sage grouse, a former candidate for protections under the Endangered Species Act. In many states, there was a wide variety of collaborative efforts made to protect sage grouse in the hopes of avoiding a listing under the Endangered Species Act based on the potential economic ramifications that a listing would create. I used a panel of informants model with potential participants identified through media and publicly available documents. Some were also identified by other participants. And interviews, which were on average an hour and 15 minutes long, took place between late 2015 and mid 2016. After asking each participant how they would define best available science, I took those responses and coded them for the various attributes that were being proposed and organized those into themes, and then compared all of those elements across the different stakeholder groups, which you see here. We have federal officials, environmental advocates, scientists, state officials, affected industries, and local officials. In this context, affected industries includes the livestock industry, oil and gas, and mining. And I also point out that there are many federal and state officials. That is reflective of how broadly based these conservation programs were. There was just a lot of different agencies and offices involved, and that's reflected here. 5 major themes emerged from this data. The most dominant theme came from the idea that you need to take into account policy considerations when making that definition, both in terms of whether the information is usable, as well as the importance of professional judgment in terms of incorporating that information with other elements of decision making. Technical validity was also on the forefront of most participants' minds, both in terms of the source of information as well as the process by which it was generated. Not surprisingly, all of the scientists who were interviewed highlighted the importance of technical validity as being critical to the best available science, as did most agency officials, environmental advocates, and to a lesser degree, state and local officials. One group with slightly less frequency of mentioning technical validity was industry representatives, with 4 out of 11 participants mentioning these elements. Closely following technical validity was the number of participants who stressed the importance of including a diversity of information, and that a critical part of the best available science is how you interpret it and apply it to the policy context at hand. And the 5th theme regarded issues and concerns that many participants had regarding the use of the best available science as a metric, given the ambiguity of the term and other considerations. So zeroing in a little bit more on technical validity, federal officials, environmental advocates, and scientists were most likely to use the source of information as a filter for vetting its credibility, particularly in terms of the peer-reviewed research that's peer-reviewed and published in academic journals. However, state officials and industry representatives were more likely to refer to the process that science was generated with, whether it used rigorous methodology or whether it was done by somebody with scientific training, regardless of whether or where it was published. Peer review, as we all know, is often considered the gold standard for how we view good science, and that's definitely reflected in most of the responses by scientists about the role of peer review in the best available science. As illustrated here, where one scientist observes, the best available science is what reflects the peer-reviewed literature. The system is not perfect, but that is where we have the best chance at getting something close to the truth. A slightly different perspective was reflected by one state official who called for a broader vetting process. He says, call it a vetting process because peer review is so specific. I get upset when people discount anecdotal information because it's absolutely valuable, arguing that, broader considerations need to be had for what types of information are being used in decision making. Which leads us to this element of diversity and what sorts of diversity of information we are including. Many stakeholders expressed a concern that best available science could be interpreted too narrowly and argued instead that a diversity of information types and sources should be considered and integrated, especially information from multiple academic disciplines, including human dimensions, as well as local knowledge and anecdotes. Most scientists highlighted the importance of diversity both in terms of type and source, with half of those highlighting the importance of integrating local knowledge specifically and in order to provide for a context for more formalized scientists. Meanwhile, environmental advocates did bring up ideas related to different types of formal science. None of the 6 interviewed mentioned anything regarding a broader form of diversity, including things like local knowledge or agency data. This question of informational diversity was illustrated well in the discussions about choosing a monitoring protocol for some voluntary conservation programs for private landowners in Oregon, where landowners expressed a fair amount of frustration because they felt that the agencies were too wedded to one type of science in the form of their habitat assessment framework for sage grouse. They argued that they understood this was very well established, that there was a lot of data behind it, but they also argued with the level of detail in the monitoring and the plausibility of that happening in an effective way, and argued that the agencies were often unfairly dismissing some of the ideas that were coming out of the landscape ecology literature particularly regarding the interactions between wildfire and invasive species, and some modeling approaches that they argued would work just as effectively looking at broader vegetative communities, and that would be easier to implement rather than the detailed measurements associated with the habitat assessment framework. Moving on to interpretation and application, more than half of the participants observed that, even if you have technically perfect information, it would still need to be interpreted and applied to the specific context of the problem. And federal and state officials were the most likely to include these types of concerns in their definition, which is reasonably so, given that they're often the ones trying to apply it. One example that came up several times was, how do we incorporate information to model the presence and distribution of sage-grouse habitat? This one industry representative says, where it's important to the decision, the science better be the best you can do. But you also have to think about whether it can help. For example, the sagebrush cover map. Use the best available information, but best available for what purpose? Because different types of information have different values. The land fire series, which he argues is locally flawed, but is arguably the best available from a national perspective, arguing that we need to take that level of scale and, what value are we pulling from that information into account. And notably, very few of the environmental advocates brought up these types of concepts in their comments. Moving on to policy considerations. This was interesting because, again, they were asked for their definition of the best available science, not asked their thoughts on its application to policy. But overwhelmingly, participants in all groups, but especially federal and state officials, highlighted that the best available science concept could not be defined without explicit connection to the relevant policy context, and argued that this points to a particular value for collaboration. Specifically, many noted that the information needed to fit within the decision needs of the policy itself, and that professional judgment was necessary to consider the best available science in the context of uncertainty together with a diversity of other perspectives. That uncertainty, this concern about availability of information and its associated uncertainty, was highlighted by almost half of all participants, and many of them pointed to the need to have some sort of established process for incorporating future changes in scientific evidence. And as with the other themes, environmental advocates were the least likely to highlight these sorts of policy considerations. And this is illustrated in, kind of the way in which different participants spoke about that uncertainty. So again, as with many of the themes, there was some broad agreement, but once you get to the details, things start changing a little bit. Here, an environmental advocate and a local official are wrestling with the uncertainty of how uncertainty should be addressed, but with subtle differences in the way they suggest, that should be done. Both recognize that science doesn't provide a final unbending answer, but the advocate holds firm with technical criteria while the local official moves towards greater flexibility in light of uncertainty and uncertain information, probably especially in the context of some of the political credibility that is often also been highlighted as an important element of decision making. All right, so issues and concerns with the best available science as a metric. The biggest issues that were raised about best available science as a metric for decision making were related to agency capacity to meet that standard, especially due to the ambiguity surrounding the concept, as well as the existence of bad or biased science and the possibility of inappropriate political influences. State officials and industry representatives in particular highlighted concerns both about agency capacity and the potential for bad or biased science. And you can see degrees of optimism and pessimism in terms of how politics and science interact. Here we have one scientist saying, you know, science isn't completely free of people's biases, so you have to take what you get, combine that with your practical knowledge and what you learn on the ground, and you know, there you have a lot to work with in terms of making a decision. Whereas an industry representative looked at it and kind of circumspectly observed, you know, the best available science ought to mean that there's a rigorous search for scientific information. But that's not how it actually works in practice. It's whoever is most aggressive in putting their science in front of the agencies involved that will influence the direction the agency takes. So that is the last theme. In terms of what conclusions we can draw from that, one, on several of the themes, there's fairly broad agreement, but differences emerge between groups or even sometimes within an individual's response regarding these dual needs of technical and political credibility, particularly when we start thinking about the noticeable trend for the environmental advocates to stick to a very technical definition of best available science, while several of the other groups moderate that with other concerns, including the diversity of information. Stakeholders who were interviewed consistently noted that decisions might be based in science, but they're inherently political. And this highlights an important role for a diverse set of perspectives to help evaluate and interpret the information being considered. One possible concern is that with the variations in how stakeholders perceive and apply this concept, such as those that were illustrated here, that could possibly lead to increased conflict if it's not addressed openly and early in the process. And so there's a variety of topics based on the results here that might be useful to incorporate into discussions, like how are we going to assess credibility, strategies for integrating diverse types of information, how are we going to deal with uncertainty, and how are we going to manage bias. And having those discussions may help to get participants on the same page and have more constructive conversations. And with that, I will end and show you my references. And I look forward to any questions or comments you might have, and I will see you later. Thank you very much. Bye-bye.